This is the notes video for Algebra 1 Summer School, Unit 2, Lesson 2, Graphing Lines. All right, one of the easiest ways to graph a line is to use what we call slope-intercept form. This is a really common form of a line that mathematicians all over the world, every Algebra 1 student is going to learn this. The general setup of this line is written as y equals mx plus b. The y and the x are just our variables, like our x-axis and our y-axis. The m and b represent other things. M represents our slope, and our slope is rise over run. We did this in the first lesson. The change in y, or the change over the change in x. Or we also had a formula, y2 minus y1 over x2 minus x1. That's what slope is. That's always the m there. B we call our y-intercept. Now the m and b, the slope and y-intercept, give us all the information that we need in order to graph a line correctly. When I graph a line that's in slope-intercept form, the two pieces of information that I need to identify first are this m and b. M is always the number in front of x. M is married to x. There's no x in the slope, but it's the number that is in front. So in this example, the slope of the line is 3 over 5. The y-intercept of the line is 2. It's the number that's by itself. B is by itself. Now when I'm going to graph a line, I have to make sure this equation is in slope-intercept form, identify the slope and y-intercept like we already did, and now we're going to graph. I always start at the y-intercept. We call that our starting point. Well, here the starting point is at 2. So I go on the y-axis. The y-axis is the up and down axis, and put a point at 2. Then I use slope, the rise over run, to help me get to the next point. I'm always going to rise. This one is up 3 because it's positive. So I'm going to go up 1, 2, 3, over run 5. The run is always to the right. 1, 2, 3, 4, 5. I'm going to continue plotting points until I filled up my whole grid so my line is as accurate as possible. So I continue to go up 1, 2, 3, 1, 2, 3, 4, 5, over. Now I've gone as far as I can to the right, so I'm going to graph to the left. I do the opposite of what I just did. So I end up running the other way, down 3, running 5 the other way. Down 1, 2, 3, running over 5. Then I take a straight edge or ruler, and I draw a line between those points as accurately as I can. Okay. Always use a ruler. I'm a stickler for straight lines, but always use a ruler to graph your lines here. All right, let's look at another example. It says graph the following line that's given to you in slope-intercept form. It looks like my line is in the form y equals mx plus b, which allows me to identify the slope here of negative 2. The y-intercept is the number by itself, which is 3. So when I graph a line, I always start with that y-intercept of 3. I'm going to put a dot at positive 3. Now this time I'm going to look at my slope. My slope is negative 2, which means I'm going to end up going down for my rise, but it doesn't look like a fraction. But I'm going to tell you, and you got to trust me here, that negative 2 over 1 is the fraction negative 2. That means that when I start here at 3, I'm going to go down 2, right 1. Down 2, right 1. And I'm just going to continue to go down 2, right 1 until I run out of room. You can put an extra dot on there. Then I'm going to go the other way to continue my line in the other direction. Okay. Then I take my straight edge and I continue to fill all those lines in nice and straight, although I didn't quite hit all the dots there. There we go. That's a little bit better. All right, so that's this line with a y-intercept of 3 and a slope of -2. It is going down from left to right. All right, now those were lines with positive and negative slope. They were slanted lines. But we have strange lines. We talked a little bit about vertical and horizontal lines in lesson 1 when we talked about slope. Horizontal lines go left and right. All right, this is a horizontal line right here. Now, 2 points that are on this line. Well, there were 2 points kind of darkened in on your paper here. That looks like we have the point -3, 4. So I'll write that down here, -3, 4. And this point is 5, 4. So those are 2 points that are on this line. When I look at those ordered pairs, it appears that they share the y value of 4 in common. So because they share the y value of 4 in common, and this line cuts across the y-axis, the equation of this line is y equals 4. It's always the y value that the line cuts through. Vertical lines work in the opposite way. I have a vertical line here, and I have a couple points that I've darkened in on this graph as well. 2 coordinate points that are on this graph are 2, 4, and 2, -1. So I'll write these down here so it's easier to see. 2, 4, and 2, -1. It looks like this line and these 2 points share the x value of 2. Remember, ordered pairs always come in the pattern x, y. So just as the same way as horizontal lines are y equals, this vertical line cuts through the x-axis and shares the x value of 2. So that's the equation, x equals 2. Horizontal and vertical lines seem super simple, but once we do a lot with slanted lines, these tend to be things that are missed. So it's really important that we get a good understanding of vertical and horizontal lines to start. Okay. When I look at those 2 lines, this is just a review of what I just said. A horizontal line is always y equals, it says a constant. A constant, if you want to know, is a number. It's always going to be y equals 10 or y equals 2 or -1 or different equations like that. Vertical lines are always x equals a constant. Again, a constant is a number. There's only going to be one variable, and it's the x equals. Now let's try to review what we did in lesson 1. So state the slope of the horizontal line above. That's this graph on the left. Well, when I had a graph that was horizontal that wasn't going up or down, we said that slope was 0. When I looked at this vertical line, oh, I went the wrong way. When I looked at this vertical line that was going up and down, that was slope, dude's curse word. That slope was called undefined. All right, so let's go through and let's practice identifying different vertical and horizontal lines. Okay, I have a few problems here. It says write the equation of each line. I need to identify first, before I can write the equation, what kind of line this is. Well, this line is vertical, and a vertical line is cutting through the x-axis. Because that's the axis it cuts through, it's x equals, and the x it cuts through is at 3 over 1, 2, 3. The second line also appears here to be vertical. So again, because it's cutting through the x-axis, it's x equals, and it looks like it's going through -4. Question C here has a horizontal line. The horizontal line cuts across the y-axis. So my equation is y equals -1. It's 1 below the x-axis there. Okay. All right, now this next equation, or this next example, asks us to graph each strange line. So when I have to make a graph, I have to think about what axis we're going to cut through. The x equals 6 cuts through the x-axis. So if I'm going to cut through that axis, I have to be vertical. So I go through x equals 6, which is this point right here, and I'm going to use a nice straight edge to make that line. So I'm going to go right up through there, and that's the line x equals 6. Y equals -4 has the y, which means it goes through the y-axis. So that means I have to have a horizontal line through -4. So when I make this horizontal line, I go down to -4, I go there. It doesn't have to be dotted, that's just the line that my graph made for us. Finally, just like the last one, y equals 8 goes through the y-axis at the value of 8. So I'm going to go up here and draw a nice horizontal line through 8. All right, now these last examples don't have strange lines. They are just two examples of writing the equation of a line given the graph. So what we do this time is, in order to write the equation in slope-intercept form, which is y equals mx plus b form, we have to identify the m and b. Remember, m is the slope, and b is the y-intercept. So the y-intercept in A looks like it is at 2. So that's our b. My slope I measure as my rise over run. So if I start at the left point, it looks like I go up 2 and run over 3. So I have a slope of 2/3. Now that I know m and b, I can write the equation. The y equals is always the same. M, we said, was 2/3. I always have an x plus 2. That's my b. That is the equation of the line that's graphed. In B, I first identify all the same information. I have a y-intercept, which appears to be at 1. Then when I have this second point, I need to use it to find the slope. The slope looks like it's going down from left to right, and it looks like it's going down 1/5. All right, because my graph is going down from left to right, I'm going to have a negative slope. I can write the equation as y equals -1/5x, don't forget the x, plus 1. All right, let's see. We have one more question here. All right, this is an OST question from the Ohio State test. All right, so in order to be successful for this OST style question, you need to have a graphing calculator. You don't have to have a graphing calculator, but it's going to make this question so much easier. So we're given the equation of a line, y equals 1/2x plus 3/4. We're going to select all of the points, so you might have multiple answers, that are contained on the graph of that line. Well, even if you don't know where to start, it says we have a graph of an equation 1/2x plus 3/4. So what I would do is go to my calculator. So I have my calculator pulled up here. In order to graph a line, I go to y equals. And on that y equals, I'm going to type the equation. Now, if you remember how to make a fraction, this is good review for you. I'm going to click alpha, y equals, enter. And I'm going to type the fraction 1/2 for 1/2 x plus the fraction 3/4. Okay. That's the equation of the line. Now, I'm going to look at the picture. I hit graph, and that's the graph that they just wanted you to make. In order to decide whether the points 0, 1/2, 0, 3/4, any of those are on the equation, it's going to be a little bit harder than just looking at the picture. But here's a strategy I would start with. I would first, we already graphed, that would be the first thing I do. Secondly, I would look at the table. The one that's going to be really easy to look at for the table is to see what the y value is for x equals 0, because that's going to be able to at least tell me which ones I can check off for the first two. So when I go to the calculator here, I hit second graph to get through the table, and I'm going to scroll through this table until I see where x equals 0. Looks like I have x equals 0 right here, and its y value is 3 over 4. So I can go back to my paper here and choose that 0 3/4 is on the line. So definitely 0 1/2 is not, that was not on the table. But now I have to choose between 3 over 4 and 1/2. Those are the other two x values left, 3 over 4 and 1/2. When I look at the table on my calculator, they're going up by 1, not 1/2 and not 3 over 4. So I'm actually going to go back to my graph, and I'm going to use what we call the trace feature. When I go to second trace, this first option, number 1, is called value. I'm going to click enter on value, and down on the bottom left here you see an x equals with a flashing cursor. I'm going to start by typing in 3 over 4. Okay. So I'm going to go alpha y equals enter, 3 over 4. Oops, I didn't like that. I guess I'll just type 3 over 4 the old-fashioned way, 3 divided by 4. When I hit enter, it takes me right to the cursor there, 3 over 4, and it tells me that the y value is 1.125. All right, well, let's look back at these. 1.125. Oops, 3/4. Well, 3/4, 1.125, that's definitely not 3/4 0. And 1.125 is also not 1/2. So it works out that neither of those options are on the line. So the last one I have to choose is x equals 1/2. So I'm going to do the same thing I just did. I'm going to go second trace, click enter on 1 value, and type in 1/2 or 0.5. When I do that for 0.5, I get the output value of 1. All right, when I look at here, it does in fact have the ordered pair 1/2, 1. So out of all 5 of these options, the only points on the line are 0 3/4 and 1/2, 1. All right, that's the notes for lesson 2, graphing lines. You can go ahead back to Canvas and choose the practice. The key and a partial practice video are there waiting for you.